Welcome to another edition of Indium's Quick Fix Hacks. Today, we're going to check out application performance enhancement using the Angular framework.
Application development in the modern times have become easier with availability of a plethora of tools and framework. With agile practices, the turnaround for adding features have also reduced. Ever experienced a scenario where the application slows down as the features are added? More often than not, the answer would be an yes. Take the example of the application in this video, which has loads of features included and it takes forever to display the initial screen, which is frustrating for anyone who is trying to use the system. The statistics in the screen shows that there are a lot of scripts that have been running and hence delaying the loading of the screen. The reason for the application slowness was attributed to two factors. One, there were numerous modules and submodules, and the way the components of the modules were being loaded. Here we have a dashboard module which comprises of many submodules. When we see the dashboard module, we have the submodule components imported as and when the features were added, which resulted in a huge monolithic file. This is not only increasing the bundle size but also resulted in the rendering time being higher for loading the dashboard UI. Also, having to maintain a huge monolithic code has its own challenges in terms of maintenance and updates. We enhance the performance of the application without compromising on the cost and quality. Most of the times, the immediate solution is to increase the compute power or adding more memory and storage. However, this comes at an additional cost. Is there an alternate solution? In this application, we were able to minimize the loading time not by adding more infrastructure but by tweaking and using the framework features effectively. Firstly, performing a little bit of housekeeping by organizing the modules and importing only the needed components specific to that module, and then the routing files were optimized to be loaded in an as needed basis, or also known as lazy loading. Each module has its routing path defined. On the app routing modules, submodules were loaded and those will be rendered based on lazy loading, which meant that the module components will be rendered only and whenever its path is accessed as defined in the app routing module file. By doing this modularization and lazy loading, only the needed components and modules are loaded. This reduces the static bundle size and the amount of active memory that is needed to load these components. The huge monolithic file is broken down into chunks, and that makes it easy to read and maintain as they are well organized and compacted. Having done these changes, when the application is launched again, the load time is considerably reduced by 60% and the page loaded under 10 seconds as opposed to 30 plus seconds earlier. By doing a minor tweak in the way the components are laid out and loaded, we were able to drastically alter the performance of the application without any additional cost on the infrastructure. The graph in the video shows the reduction in the load time and the time taken for the modules to load and render. This proves that in order to have a faster application response time with a fully loaded application, it is imperative to understand the inner workings of the tool and framework in order to take advantage of the features that are being offered. Hope this video was useful. Thanks for watching.